we can start with today's class. Why we always use int instead of short or byte or even for storing even two? Nothing like that. You can store, okay, I believe you guys know about the range as well, so you can store as well. For one of LIT code questions, I got TLE when I submit answer. Okay, I will tell it. 1 second. Let me just connect my charger, guys. Just give me 1 second. Okay, coming back. Coming to the range of values, I think in the very first class, I have given you the formula for range of values. So if you're storing values between -128 to 127, I have no issues. Go with the byte. Go with the byte. No issues. It will work. But the thing is, the reason I'm using integer is when I'm solving a code, I see the constants properly. And based upon the constant, I decide an integer type, right? If I show you the question, any particular question as such. Yeah, here if you see, can you see something called constant? Let me just highlight if it is not visible. You can see constant, right? 1 less than n equals to 10 is equal to 4. So this is telling me the number that I'm going to operate upon, that will be the range of 1 till 1000. I cannot use byte here. I cannot use short here because that is beyond this range. So I can definitely go for int. That's why the reason I go for int. Similarly, any questions I solve, and that is where the constants are provided to check a particular data type, to check the complexity, in terms of space, time and space. We'll come to that discussion, but just to tell you, how do I know whether to use int or particular long or byte or short? I check from here because constant will tell me what kind of values will be used to test against the code. Okay, so all of these test cases that you will see, let me show you any one of them. Your code is tested against multiple test cases. So if I see 8 test cases, I mean, these are not that good. Usually there will be more than 50, 60 test cases. So if I see this, yeah, this should show me the number of test cases quickly. Okay, 480 test cases, right? It can be very large number of test cases as well. So these test cases that are going to be going against, I should know what kind of values or what is the size of values I'm keeping here. Okay. Based upon that, I determine my data type. Okay. And obviously, as a good developer, always try to optimize, but not at the cost of test cases not passing. That should not be the condition. Coming to second answer, for one of the questions, I got time limit exceed. Good question. I'll discuss all of that in more detail about your time and space complexity. Why specifically you get a particular TLE? That's why there's CP trick, which is used to pass all test cases. But anyhow, if you're interested, we'll discuss. Otherwise, we'll skip. Just to tell you the TLE, you get TLE because with every test case, there's a proper test time limit which is assigned to it. Okay, imagine this. You will find this kind of thing, time limit 1 second. 1 second per test case, something like this. Okay, yeah, that's what I'm saying. So with every test case or the number of test cases, there's a time limit which is assigned to it. Whenever you're getting TLE, it means few of the test cases are successful. Few of the test cases successfully passed, but few of the test cases are not passing within the stimulated time. Okay, they are not passing in the stimulated time. So what you need to do is you need to decrease the time complexity. So whenever you get TLE, just decrease the time complexity, it will pass all test cases. Why acceptance is changing when we submit multiple times in LIT code? Guys, it runs on a bucket. Understand this. This part, if you're talking about this acceptance, let me check. You're talking about the acceptance when you submit a particular solution, it changes like this MB, that millisecond, and number of percentage, right? Like 80%, 90%, whatever. That's what you're having, right? Guys, LIT code works on a heap of bucket. Heap of bucket in the sense, it takes the data of last 1 hour submissions. So in last 1 hour submission, if anybody has given better solution than you, then it will rank you accordingly, like 20%, 30%. It is not global, it is not all time. It is last 1 hour. So it runs in bucket of data. Okay. Based upon that, it keeps on changing. Just to iterate you the example of it, the TLE, I was giving this is still active by the way. So I'm at my country rank is 10, as I can see, 1, 2, 3, 4, 5, 6, or not 10, it is 9. So this is what I was giving, and this is the last problem where I'm getting TLE. So just to tell you, the idea of getting TLE is that your code is correct, but is that it's not passing again the stipulated time. That is the reason you get a TLE. So that coming back to Sublime. I got TLE for same problem for ridiculously high size array, more than 5,000 elements. 5,000 elements is not more. 5,000 is very small number. But anyhow, when the reason of you are getting a TLE is that the time limit, all of your test cases are not passing in the stipulated time. So those test cases which are not passing in the stipulated time, they are giving you TLE. Okay. Why does that happen? We'll discuss detail in time and space. I can also tell you which exact test cases are failing. For example, you will see 5 test cases passed, or let's say 7 test cases passed, 3 are giving you TLE. Why are they giving you TLE? We'll discuss that. But the idea is whenever you get TLE, can we discuss this problem? Okay, I'll do it. Whenever you get TLE, the idea is, or the solution for that is reduce time complexity. If you reduce the time complexity, definitely it will pass within the stipulated time. Okay. Cool, guys. I think now we can take up metrics or 2D arrays and we can discuss from there. Shall we start, guys? Just let me know in the chat. We can start with metrics / 2D arrays. Cool. We have done the 1D array. We can definitely go with the 2D arrays. If you remember in 1D array, what do we have exactly is 1D array. We create set of values. Let's say 1, 2, 3, 4, 5, whatever. That is called one-dimensional array. And this D is taken only from the dimensions. So one-dimensional means it's going to be either horizontal or it's going to be vertical. But when we say 2D, we are talking about two-dimensional. Similarly, you can extend it to 3D array, 4D array, KD's array, whatever. 2D array specifically means you're going to have 2 dimensions. It's going to be a row, it's going to be a column. What does that mean? So just like my value was initially growing here, now it can grow here also. So up, and up. That is the idea of 2D arrays. So you are growing both horizontally as well as vertically. So horizontally, basically rows plus columns. Initially, there was only rows or only columns, whatever you call. Now they're going to be row plus column. So if I just give an example of 2D array, you can take 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5, and put it under one part. That is example of a 2D array. That is the definition of 2D array. Instead of storing only one particular rows or columns, you can contain both rows and columns. Is this part clear to all? Just let me know. Okay. Now coming back to the code part, how do we do the code analysis? Let's quickly discuss, then we'll solve a few questions on it. In the code part, if you remember, we used to create an array, integer array, and this. Because since it is only one, it's only one dimension, that's why I used to write this and we put a semicolon. And that was correct. 2 for loops. Yeah, I'm coming to that only. I'm coming to code part only, that I'll come. So you can say integer array of n. So you can just write the code and you can iterate over all the values, simple for loop. And that is correct because you have only one dimension. So this code is telling you only one dimension. Data is stored in only one dimension, whether you call it row or you call it column, doesn't matter. In case of matrix or in case of 2D arrays, I'm going to have 2 dimensions. So I'm going to name matrix. I need 2 dimensions. First dimension I call row, second dimension I call column. Okay. This is the syntax for creating a 2D array. This is for number of rows. This is for number of columns. This is telling me this is 2 dimensions. Similarly, if I want to extend for 3D arrays, I can do something like this. Row, column, height, something like this. Now this is telling me there are 3 dimensions which you have to initialize for. This part clear to all? When you write array of n, you're talking about only one dimension. Either you call row or column, doesn't matter. When you're talking about 2 dimensions, there has to be 2 dimensions to be satisfied. When you're talking about 3D, there are 3 dimensions. Similarly, 4D, 5D, 5, 6D, 8D, KD. Okay, extend up to whatever dimensions you want. My focus is about 2D dimensions, right? If you remember traversal an array, traversing a 1D array, so I will iterate with 1D array and 2D array. Is there a maximum capacity on dimension? No. There is no maximum capacity on dimension. There is a capacity on the size of the array. There is no capacity on the dimension of the matrix. Why there is a capacity on size of array? That's a really good use case in itself, and that's the reason why linked list was created. There's always a reason, guys. A particular data structure is created is because somebody has some limitation. That's only a new thing comes into picture. Just to give you an idea, I will not discuss that in much detail. I'll discuss that when we go to linked list. Just to give a brief idea, integer array 1000. Do you guys know the array memories are stored in contiguous places? Do you guys know that? Have I covered that in the class or no? First, let me know that. If I've not covered, then there's no point in discussing that. I've covered in class. Okay, it is covered. Cool. So what does contiguous places means, by the way, in case anybody doesn't know? If it is 1000 address, it's 1001 address, 1002 address, etc., etc. So between the places, every integer take 4 bytes. It's going to be in the same place. Okay, there is no going to be a space between them. It's a contiguous memory. Now, what is the size of this array in bytes? What is the size of this array in bytes? Quickly tell me. One integer take 4 bytes. How many integers? 10,000. Total is 40,000 bytes. Or roughly it's going to be 40 kilobytes. Everybody knows, right? 1024 bytes make 1 kilobyte. So roughly it's going to be 40 kilobytes. 39 point some it will come, but roughly I'm typing as 40 kbs. This is fine. But what if I do something like this? And just to give you an idea, where is this 40 KB used? Where is this 40 KB memory created? It is created in your RAM. Your primary memory, your RAM is taking this space in 40 KB. If I run this program. Now, you guys know your RAM. Your RAM is usually 4 GB, 8 GB, 16 GB, whatever you guys are using. Mostly it's going to be 4, 8, or 16. I'm not sure if anybody is using more than 16, but it's going to be something like that. So if you are occupying 40 KB out of your 16 GB or 4 GB memory, not going to be an issue. But if I just copy paste and I change it like this, I make it like this, I added 6 zeros. So this will become 4 into 10 to the power 9 bytes. 4 into 10 to the power 9 bytes, that will become 4 GB. That is now where I will have started having issues. Why? Suppose my RAM is 4 GB. Can I allocate the complete 4 GB just for creating this array? And remind you, this is in contiguous memory. This is in contiguous memory. Contiguous memory in the sense, just to give you an idea on RAM, you guys know that's your program is not the only thing which is running your RAM. So if I just draw a memory diagram, XX and something like this, your memory diagram to explain you how does your RAM look like. You can just inspect as well how your RAM looks like. Wherever you see a dot, that is a free memory. Wherever you see a X, that is occupied memory. Okay. Now, suppose I'm using multiple applications. I'm using Google Chrome, which is occupying a lot portion of my RAM. I'm using whatever. I'm listening to Spotify. I'm watching a movie. So let's say any XYZ application. Let's say VLC have opened. And this is my VS Code also where I'm coding, right? Now imagine this is your 4 GB. Okay, this is the total bifurcation of your 4 GB. And you have like 1 GB space available here and 100 MB available here and something like 250 MB available here, etc., etc. And some, let's say 500 MB available here. Your RAM is always occupied in chunks. It's never going to be continuous. It's occupied in chunks. So this is the current status of your RAM. If you go in VS Code and you write this code, what is the first thing that's going to happen? This will go to the compiler. It will say, hey, compiler, I want 4 GB of RAM. Compiler will say, my total capacity is 4 GB. I have only the extra space of 1 GB at max. Remember, array works on contiguous memory. So it cannot do this 1 GB plus 100 plus 250 plus 500. That it cannot do. It will only find the maximum size which is available as contiguous chunk. This is one contiguous chunk, 500 MB. This is one contiguous chunk, 250 MB. This is 100 MB. This is 1 GB. So compiler will say, the RAM will say to compiler, I only have 1 GB of contiguous memory. It will say, I want 4 GB. It will create conflict. At the end, array will not be created because nobody is going to negotiate. Array will not negotiate. Array will say, I want contiguous only and I want 4 GB only. And the RAM will say, I don't have it. So at the end, the array will not be created. Try creating this array, you will get an error by yourself. Okay, this is the limitation. That's what I was saying. There's a limitation on the size of the array. There's no limitation on this. As long as you cross this number, whatever the maximum size available, then it will start giving you problems. Okay, that is the approach. Is this part clear, guys? That I usually cover at the time of linked list, but somebody asked, so I covered it. Coming back to our topic, traversing a 1D array. Okay, and in case of traversing a 1D array, I just write like this: I equal to 0, I less than n, I plus plus, because I know index goes from I to n minus 1. And then I say array of I. So I know, okay, I'm just traversing for array of I. I can find all the values. That is correct from a 1D array. And if I have to traverse a 2D array, and before that, initializing, then we'll go for traversing. If you have to initialize 1D array, what would you do? You will simply write integer array and whatever size you want to give it. For example, 3, and array you are giving 1, 2, 3. You properly initialize it, right? Similarly, if I have to initialize a 2D array, now I need to define both row and column. So I will say integer array 3 and 2. So first value is the number of rows. Second value is the number of columns. So I have to define something like first is the number of rows, second is the number of columns. So it's going to be 3 rows and every row will have 2 columns. So 1, 2, 3, 4, 5, 6. That is how you define an array or initialize an array. Okay. Just the same thing. The only thing is here it has only one dimension. So that's why you keep it only in 1, 2, 3. 3 values it is taking. How many values this is taking? This is taking 3 into 2. 6 values it is taking. Where 3 is the number of rows, 2 is the number of columns. Rows are the horizontal one. Just to write it. Row means horizontal one and column means vertical ones. Okay. So how many rows I'm going to have? I'm going to have 3 number of rows and I'm going to have 2 number of columns. This is my first row. This is my second row. This is my third row. 1, 3, 5 is my first column. 2, 4, 6 is my second column. Horizontal things are called rows. Vertical things are called columns. Yeah. And total size of matrix if I have to define, or size of 2D array if I have to define, that is going to be rows into columns. This part everybody clear? This part everybody clear? Okay, cool guys. So if I have to ask you how much memory this array or this whatever matrix is occupying, what would be your answer in bytes? 6,000 bytes. Why 6,000 bytes? One integer take 4 bytes. Total number of integer is 3 into 2, 6. 6 into 4, 24 bytes. 24 bytes is taking in the memory. Okay. This is taking 12 bytes. This is taking 24 bytes. Anyhow, coming back. Now coming to how do I access or how do I traverse the values? So I know in my array, let's take this array only for reference. It will be good. Copying this and pasting here. So just deleting this, and deleting this. I'm traversing a 1D array and here I'll be writing traversing a 2D array. So in the 1D array, if you see, I'm just giving the size, whatever size, I'm iterating over all the values. So first it will go for 1, then 2, then 3. Here, if I have to iterate over 2D array, I need to know one thing very clearly. If you see here, every element is uniquely identified by just index. In case of 1D array, if I have to go to an element, I can uniquely tell it by what index it is. Agree? There is no way possible that at the same index, 2 elements will exist in a 1D array. Agree? There is no way possible that at one index, 2 elements can exist. Every element is uniquely identified by their indexes. But in case of a 2D array, if I'm talking about a particular index, let's say if I say array of I, that will give me ambiguous result. Why ambiguous result? If I talk about array of 0. Now, since it is a matrix, array of 0 means this part. So either you are referring to 1 or you're referring to 2 or whatever it is. This is the first complete row. Which element in complete row you are talking about, that I cannot determine by using one index. Understand the difference? In the first 1D array, you give me the index, I can tell exactly which element you are talking about. In case of a matrix, if you just give me the row or if you just give me the column, I cannot determine the exact element which you are talking about. If I say this array 0 or I say this array empty and 0. Now in the first part, I'm talking about first row. First row can be very large, right? 1, 2, 3, 4, 5, whatever I have there. Now, which element you're talking about, I'm not sure. If you're talking about first column, so 1, 3, 5 is first column. Which element out of 1, 3, 5 you're talking about, not sure. So to uniquely identify element, I need both row and index, both row index and column index to uniquely identify an element. Is this part clear? Just let me know. Is this part clear? Just let me know. Okay, so in order to uniquely identify, I must know both the row and column index. Uniquely identify an element. need both row and column index. Somebody was asking, do I need to create 2 for loops? That is the reason for it. That is the reason for it. Okay. Uniquely identify an element, you need both a row and column index. Okay. So if I'm talking about indexes, so array of 0, 0, I'm talking about first row, first column. So this is my first row. Now I'm talking about first column in the first row. So this is 1. Now I can uniquely identify all the values. Okay. Similarly, array of 1, 1, I'm talking about second row, second column. So second row, second column, I'm talking about 4. And take any random value, for example, array of 0 and array of 2 and array of 1. Can you guys tell me which index I'm talking about? This will be actually this. Okay, I've repeated it. Row 2, column 1. Yeah, now tell me. Array of 2 means, array of 2, 1 means I'm talking about third row and second column. So if I go to array of 2, that will be third row. Inside the 2, I'm talking about second column. So this is 6. Okay. I believe indexing is clear to everybody in the array or 2D array. Indexing, everybody clear? Okay. Now let me just introduce you to a square matrix, rectangular matrix, then I will come to the jagged arrays. What is a square matrix and what is a rectangular matrix? Let's discuss that also. Guys, this is simple pure mathematics which you have learned in geometry. A square is just a rectangle which has length equal to breadth. This is a must you have learned in class 5th or 6th, correct? A square is just a rectangle which has equal length and breadth. That is how you have been introduced in the geometry, and that is correct. In square, all sides are equal. That's why it is called square. So if I have same number of row equal to column, then I will say this is a square matrix. But if my row is not equal to column, then I will say it is not a square matrix. As simple as that. So square matrix is actually a subset. Rectangular is actually the subset. Rectangular is the superset. Square is just a subset. Every square is a rectangle. I believe you guys know that, right? Every square is a rectangle. Every rectangle is not a square. Basic geometry things you should know about, right? So only condition is when my number of rows become equal to number of columns, then I can say square matrix. Otherwise, I can say it is rectangular matrix. Okay. Now let's do some coding part. Let's initialize some value and do it. And in addition to that, let me introduce you to vectors also. Or even if you don't want, that is also fine, but it's good to have created vectors. Guys, the limitation with arrays is that I must exactly know the size. I must exactly know the size before I want to create. If I don't want to create a runtime, I'm not allowed to create a runtime. You're getting it, right? If I'm writing like this, just like this, integer of array, and I keep it empty, and I initialize whatever value user is giving, that is not allowed. Because when you're creating an array, this size has to be created. There are many ways. Either you keep it a size, or you take a number and you initialize that number and you get that number, or you keep this and you give the values. But the idea is the moment you have created integer array, you must give it size. Otherwise, the code will not work. An alternative of that can be a good alternative, can be a vector. Okay, so I can create a vector of integer. I don't need to give it size now. I don't need to give it size later. I can keep on putting the value, and whatever value I will put, it will adjust itself. Vector everybody knows about. Vectors are just dynamic arrays, just to reiterate. Vectors everybody knows about. Yeah, same as Java. Are there vectors in Java? Array list is the symbol of vectors. Then there are vectors in Java also in the collections framework. Okay, in case you don't know about vectors, that is fine. I can teach with arrays also, but it's good to convert to vectors as well. List is dynamic. Python, guys, list is dynamic, so you don't need to worry. The idea is, let me just formally introduce vectors, then I will switch to vectors. Integer array 5. This is correct. Integer n equal to 5. Integer array n. This is also correct. Or integer array equal to 1, 2, 3, 4, 5. This is also correct. Understand the difference I'm coming to. Whenever you create an array, arrays are called static data types. Arrays are not dynamic in nature. Dynamic in nature in the sense, can I change it at the runtime? If I can, that will be dynamic. Otherwise, it will not be dynamic. Is there an array, not vector, in Python? Arrays are implemented by list interfaces in Python. Arrays, stacks, queues, all of them are implemented by list interface. So whenever like this, list equal to this list, when you're, or basically this part that we're talking about, this is an interface. So if we read the docs of Python, they have specifically mentioned arrays, stacks, queues, these data structures are implemented by this list, and they are dynamic in nature in Python. Okay. Python is loosely bound language, guys. So there is no specific. Yes, Python, JavaScript, they are like sisters of each other. They all are interpreted languages. These are loosely bound languages. They are not compiled languages. These are interpreted languages. That is why we don't define data types. If I have to create an array of integers, I have to write integer array in C++ or Java. But in case of Python, I will just type list and I will give the value and it will adjust itself. If I'm giving 1, 2, 3, it will adjust. Same list if I give, let's say, A, B, C, and D, F, it will adjust. Here, I don't need to put that it is an integer or it's a string. It will adjust based upon itself because these objects, these elements are objects actually. So objects can contain integer, variable, strings, characters, floats, JSON, dictionary, etc. Everything. That's why JavaScript and Python are interpreted languages, not the compiled languages. Anyhow, coming back here. So these are the three ways in which you can create an array. If you're creating an array, either you have to give it size. First, you can take a size in a variable, then you give it, that is correct. Or you directly give it, that is correct. Or you directly give the values. Based upon the number of values, it will determine the size. These three are the ways you can create arrays. The problem is, if I have to write like this, integer array, and keep this as empty, this will give me error. The error it will give me is, if you want me to create an array, first tell me the size, how much array you want. Got this? Can anybody think why does the error comes? This part everybody knows it's an error. But can anybody think why does the error come? Yeah, that is correct. I have not given the size, that's why error. But what is the reason that it generates error? Correct. So you understand what happens at compilation. Whenever you write this code, whenever you write array static, that's what I'm asking, why it is static. See, whenever you write this code, what happens at the compiler end? Compiler will come here, compiler will ask, this is an array, I have to store memory, I have to save memory, I have to reserve memory in the RAM. If you don't tell it which memory, how much memory to reserve, it cannot reserve. Understand the difference between reserving memory and occupying memory. Array reserves the memory. That is why it is called static data types. Vector is runtime. It can adjust the size accordingly. Vector or any other dynamic data types. So this array, it has to reserve some memory. So this compiler will come here. It will understand, okay, reserve 20 bytes of memory. If 20 bytes free is available, it will say, okay, I've reserved it. Array is created successfully. If for whatever reason that much amount is not reserved, it will throw you an error. First part. Second part, compiler will come here, n equal to 5. Compiler will come here, integer array n. Compiler already know at this moment n is equal to 5. So this will say, no problem, I will occupy again 20 bytes of memory. But if you write like this, and you just copy this and you paste it here, compiler will throw you an error. Why? First, this will come here. Compiler will say array of n. Later, compiler get to know n. But this point, it does not know what is n. So you're asking it, reserve 4 into n. Now, what is n? What is n? You have to define a specific number, how much memory to reserve. So this will give you definitely an error in compiler. Okay. Now coming to this part, if compiler comes here, compiler already know you are giving 5 values. So the size will be 20 bytes in memory. So it will reserve it. Similarly here, you're coming here, you're asking it 4 into something. Now what is that something? You have to come with a very specific number, how much memory to allocate. Otherwise, it will throw you an error. Everybody clear why you get the error? Why you get the error? Because it has to store the memory before even it goes to the execution stage. And I believe all of you know, first compilation happens, then it goes to execution. Everybody knows, right? Your program flow, you write the code. First it is compiled. If it is successfully compiled, then it will go and run. If it is not compiled, it will give you compile time error. It will not run. Okay. First compilation, then comes the phase of execution. Saving the memory, it happens at the compilation time, not at the dynamic time in case of arrays. That is why they are called static data structures. Every language array behaves same. Not every language in terms of compiled languages. Understand this. Two languages are there. Compile time, interpreted time. In terms of compile time, if it is compiled successfully, then only it will move to the execution. Execution is what you call as runtime. Okay. In case of interpreted, it is line by line execution. Okay. So there is no compilation happening before, it is line by line running the code. So even if I write 6 lines of code, line number 6 is incorrect, my program will run fine till 5 lines of code. For example, your Python and JavaScript, type anything, right? If I do something like this, is it correct or is it incorrect? Is it correct or is it incorrect? Print 10 by 0. It should throw me an exception, which is division by 0 error. It will throw you. It will. I'm not saying it will not throw you. It will throw you an exception. But if I create 10 lines before it, let's say print 10, print 20, whatever I want to do, this will run, this will run, this will run, this will throw you error. So those 3 lines, those who don't have any error, that will run properly because these are interpreted language. Line by line execution happens here. So this will run, this will run, this will run. Here error is thrown, here it will say, okay, this part I'm not able to execute, it will throw. Okay, that is where it will stop. In case of C++, Java, or any particular Golang or compiled languages, even if you give this error, the first 3 one will also not appear. Okay, they will throw you an error. That's the difference between compiled time and interpreted time. Now moving to next part, yeah, we're discussing about array. So array has a limitation of size, which I need to initialize it before. Is this part clear? Array has a limitation of size, which I must create before running. Now there are use cases where I don't know the numbers before. And I think I have explained it with an example also. I don't remember whether it was this batch or some other batch. Imagine this. Suppose you're inviting 100 guests to your party, whatever, wedding function or whatever kind of function. You're inviting 100 guests and you have only 100 plates. Now, suppose 200 people comes. They bring their +1 with them. You have only 100 plates. Can you change these 100 plates now? No. So all the 200 people will be able to eat? No. So obviously it's going to be a bad customer experience. Similarly, there are requirements where I have to change the number of values at the runtime, maybe size at the runtime, create more values or decrease more values. That's one example where you will be short in terms of resources. Second example, you called 100 people, you have 100 plates, only 50 people come. Now rest of your 50 plates are wasted. Agree? What I'm talking about is this. I'm talking about this part. If I create integer array of 10, I can store only 10 values. I cannot store 20 values. Agree? 10 is fixed. So 10 is fixed in the sense cannot store more values than 10. Agree? I cannot store more values than 10. Also, when this 10 is fixed, if somebody does this, array of 0 is equal to some value 1 and rest value doesn't initialize. So if he is using only 10% of the memory, then also you cannot do anything because you have reserved that kind of memory. Understand the meaning of reserve and understand the meaning of free. That's why it's always recommended, instead of using arrays, you go for vector and you always clear it. That's why multi-threading comes into the picture. Java is a good language because by default, it provides you garbage collection. So you don't have this residual memory. In C++, you have to do it manually with free or with clear. We can discuss that discussion anytime later. Anyhow, coming back to this, if somebody creates an array of 10, can you guarantee that the person will be using all 10 values? Can you guarantee that the person will be using all 10 values? The answer is no. I cannot guarantee. It's up to the person who is implementing. If somebody is writing this code, integer array 110,000, and he's just doing this array of 0 equal to 1. Is it a good approach? What is happening here? 9999 into 4 bytes of memory. That is purely wasted. You have just created a variable. Why you have created an array? If you have to store only one value, better create a variable. It will create 4 bytes of data, or create an array of size 1. Array of size 1 again does not make any difference. You create a variable. So this much amount of memory is wasted. But can I stop the user from doing this? No, I cannot stop the user. Can you stop anybody from doing this? If somebody writes a code, can you stop anybody from writing this? You cannot stop. It's their choice, right? You know, as a developer, its memory is wasted, but you cannot stop anybody. That is where the problem comes with static data types. When you're giving a fixed size, you cannot change the size, you cannot increase or accommodate more values. Same hand, you cannot even decrease the values. Okay, so cannot store more values than 10. No guarantee that all memory is utilized. Okay, by the way, this is called ROG memory. This is called ROG memory. ROG means wasted. Okay, this is called ROG memory. ROG means something which does not belong to anybody. That's why this is wasted memory. These are some of the drawbacks with static data types. Array is one of them. This part clear to all? Once I have given a size, I cannot increase it, I cannot decrease it. But in real-time situations, I need to increase or decrease the size. Is there an easy use case where array is preferred over vector? Pretty much all the things you can do it with vector. Same time and space complexity is not going to make any difference. Any specific use case where array is performing better than vector? Not required to be precise. That's the purpose of the vector wise, where you can create it and utilize it. Whatever you can do it array, you can do it in vector and even with better efficiency. So not required, not particular use case as such. Okay. Coming back here, 10 is fixed here, cannot store more values than 10, no guarantee that value is utilized. That is the limitations with the static data type. Limitations. On the other hand, if I go for a dynamic data type like vectors, this is the reason why vector was introduced. We can resize as that resize you're talking about that actually implements vector itself. We'll discuss that, which array you're talking about. Okay. In terms of vector, they gives you the limitation, they gives you the freedom that you can put as many values you want, you can decrease and increase it. For example, I just create a vector of integer and I name it as v, and that's it. I have not defined its size, and it's totally fine. If I want to give any value that I want to give, I can put it accordingly. So I can run any amount of loop, I less than n, I plus plus, and I can simply put v dot pushback, whatever value I want to put here. Now I'm putting n values here. I can change this n to whatever. Remember, when I created the vector, I did not say that the size of this vector is n. Whatever values I want, I can make it, I can clear it, I can even clear the vector. There's v dot clear, you can clear the vector also. So whatever code you want to implement, you can make in dynamic data type. That's the only thing I wanted to teach, difference between array and vector. So it's a good idea to switch to vector as soon as possible if you're still coding with the arrays. Okay. Everybody clear? Dynamic data types are obviously a better approach as compared to static data types. Yes, vector is like array list in Java. Vector is also there in Java. Again, I'm repeating, but it's pretty much similar like vector. In collections framework, vector is a separate interface, which is again implemented by the list interface. Array list vector, both are implemented by list interface in collection framework in Java. Same code when you write array list of integer equal to new array list of integer semicolon. This is also creating a dynamic list. Okay, same goes with vector also. Is this part clear to all guys? Just let me know in the chat. Okay, now moving back to the matrices part. So if I have to create a vector of matrix, I'll be doing something like this. Vector of vector integer. That is how I define a matrix in using vectors. What is this telling me? This is telling me a vector is containing vectors inside, and it is correct. See, 1, 2, 3, that is one vector. If I have to make it matrix of matrix or array of arrays or vector of vectors, it will be like 4, 5, 6, 7, 8, 9. So this code is telling me each value is a vector in itself. This is one vector, this is second vector, this is third vector. If you read this code, it is telling you a first vector is containing integer. This is correct. And vector is containing vectors. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This part clear to all? Vector of vectors is the same as writing. This is same as writing integer array row, column. As you write this or you write this, the same. The only difference between first and second is you have to define row and column. Here you can put any number of row and column. That's the only difference, nothing apart from that. Got it? Okay, so let's quickly write some code and then we can discuss how to iterate over the vectors. I'm writing the code here only, then we can copy paste on LeetCode and run. So I'm going to create 1, 2, 3, then 4, 5, 6, then 7, 8, 9. If I'm asking about size of matrix is 3. If I'm talking about size of, let me write, size of the vector, the size of vector is 3. Okay, so total elements are definitely going to be 9 because it is 3 into 3. 3 into 3 equal to 9. But if I talk about matrix.size, that will not be 9, that will be 3. Why? Matrix is containing list of vectors, right? First list, second list, third list. That gives you number of rows. When you say matrix.size, you are talking about number of rows. Agree? Agree? I'm talking about this. So this size is 1, 2, 3. So number of rows are 3. When I'm talking about matrix 0.size, I'm talking about this size. This size is 1, 2, 3. That is number of columns. That is the difference. Matrix.size, you're talking about how many vectors are there. How many vectors means whatever number of rows. So matrix.size will give you number of rows. Matrix 0.size will give you number of columns. 0.size, once was right, two was right, whatever you write. Okay. Why we prefer 0? It because there can be a matrix which does not contain this part. This will still be a matrix. What is the size of this matrix in rows and columns? This is a 1 cross 3 matrix. This is a 1 cross 3 matrix. Anybody who thinks it is not a matrix, let me know. Even if it has only one array, it's still a matrix. It is a 1 cross 3 matrix. Number of rows, number of columns, I can determine, right? I can create any matrix of any size. This is 1 cross 3 matrix. But I cannot create 0 cross 3 matrix. 0 cross 3 matrix does not exist. I hope everybody can relate, right? This size, if I talk about, this is 1 cross 3. Row is 1, column is 3. Similarly, I can create 3 cross 1 or whatever I want. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. If we are using array, size of matrix will be 9, right? If you're talking about array dot length, no, that will still be 3. We're talking about array dot length, that will still be 3. Okay, there you will go for size of array 0 by divided by array of 0. Just like we go in arrays, if you remember, we used to determine by the size of array as size of array divided by size of array 0. Something this we have to write. Same will go in the matrix also. Okay, that will give you. Cool, guys. Coming back here, is this part clear to all? Could the column size vary with every row? I'm coming to that only. Is this part clear to every row? That this is the number of rows, this is the number of columns. Why we are keeping matrix 0? You can keep matrix 1 and 2, but there is no guarantee that 1, 2 will exist. For example, if I delete this is still a matrix. But is there any 1 or 2? No. So that will give you an error. But 0 will always exist. At least one row, a particular array will have. At least one row, a matrix will have. A matrix will have at least one row. It can have more rows, but at least one row will have. That's why I'm putting matrix of 0. Is this part clear to all? Just let me know. That is not jagged. I'll come to jagged array. Later. Let's do some code, guys. Let's discuss some code part. Then we'll take discussion from there. I'll come to jagged part. What can be the edge cases and discuss that. So coming to LeetCode, let me just open compiler. Yeah, I think that is should be visible to all. My LeetCode is visible to all. Just let me know in the chat. Okay. Now let me just include. By the way, if you want to use any vector function, you can include #include vector. Okay. Yeah. All I'm doing inside my main is I'm creating a vector. Yeah, I'm creating a vector here, vector of vector integer matrix. Instead of equal to, this will be directly created. And after that, I'll put a semicolon. So my vector is created. Let's print cout matrix.size. We already know the output. And let's make it an handle here. Let me comment this. And similarly, see out here, matrix 0 dot size, again an and as well. Okay, and I'm going to put a comment here as well. Let me just increase this a bit so you guys can see the what I'm writing. All I've done is I've created a matrix. The size of the matrix is 3 cross 3. Matrix dot size should actually print me 3, which is the number of rows, and should print me columns. Let me change the size 1, 2, 3, 8, 10, and 11. Now you guys tell me, this will still remain 3. This should come 4. Okay, row will still 3, column will be 4. This part everybody clear? Okay, now let's run the code. Let's see the output. You can see that rows are 3, columns are 4. So matrix dot size is giving you 3. Matrix 0 dot size is giving you 4. All agree? Easy code, nothing too difficult. If you want to do it in any other language, let me know. But I think you guys are sufficient enough in your languages, so you're able to implement as well. You want somebody around to write in Java, Python, Golang, let me know, or any other language. But that should be sufficient enough to understand, right? Okay. Now, what if I have to traverse all the values or basically print the matrix? So in that case, what I will do, I'll create 2 integers. Integer I equal to 0, j equal to 0. Why I need 2 integers? Why I need 2 for loops? The reason for that is you need to define 2 variables to uniquely identify its position, a row and an index, a row index and a column index. That's why you need 2 for loops. Okay. So for I equal to 0, I less than whatever is my matrix size. So this is my row matrix size, correct? So just copy this. I equal to 0 for I less than matrix size, and I plus plus. Inside it, just copy paste this part. For j equal to 0, j less than matrix 0 dot size. So inside row, I'm traveling all the columns. Inside row, I'm traveling all the columns. And then I will be printing cout matrix of I and j. Both I and j are used to uniquely determine the index. And later you give just an handle, so to separate the values. I clear the console, I run the code, there you'll be able to see the matrix. 1, 2, 3, 8, 4, 5, 6, 10, 7, 8, 9, 11. All clear with this code, how to create a matrix, what is the, how to find the size of the matrix, which is the number of rows, number of columns, and how to print the matrix. That is the idea of these exercises. How to create a matrix, how to calculate size of row, how to calculate size of column, and how to traverse the matrix. If this part is clear, guys, just let me know, then I can move forward. Okay, now we'll come to a very interesting use case. And if I come there and Sublime, yeah, this is the final code. I'm pasting the code here as well, so you guys can check whenever you want. But I don't need to copy paste it. That's all fine. Let me introduce you to edge case. What can be the edge case with this code? Okay, and before that, let's do one more thing. I want to initialize it to a number of integers. So I will say integer row, and I will say integer column. Integer row is equal to this, and integer column is going to be this. Yeah, that's the edge case I'm coming to next. That is called Jagged. That's what I'm coming to next. Okay. Now I'm going to print cout row handle and cout column handle. Output will be same here. All I've done is I've just initialized this to some values. So you can see number of rows are 3, number of columns are 4. Or even better, just make it like rows and make it like columns. Now this look better as a user experience. Number of rows are 3, number of columns are 4, and this is a matrix. All good, correct? What if I do something like this? 1, 2, 3, 4, 5, 6, 10, or 4, 5, even better, 1, 2, 4, 5, 6. Then what else? 7, 8, 9, 10. Yeah, 2, 3, 4. Can you guys see what is the difference between previous matrix and this matrix? Can you guys see what is the difference between previous matrix and this matrix? Columns are changing. Technically, every row has different number of columns. Every row has different number of columns, correct? This is called jagged array. This is called jagged array. Okay. It is there in Java also, but technically any language is there. So jagged array means when a particular matrix will have different number of columns. Okay. Each row will have different number of columns. So if you see here, this is 1, 2, this is 4, 5, 6, this is 7, 8, 9, 10. There's no issue in creating that. That is totally fine. But the problem is come here. Matrix.size will give me the output 3. Agree? Matrix.size will give me the output 3. That is correct. What will the column give me the output? What will the column give me the output? Column will give you the output matrix 0.size. I know columns are changing. So saying that column is 2, is it correct? No, because column is different for each different values. Column is different for each different value. So I cannot say all columns are same. So use this code only when it's not a jagged array. When you're already sure you're given m cross n matrix. So you know every particular vector has m rows and n columns. Only use that place. Okay. Most of the question they will specifically mention. Jagged array questions usually are not asked, but if it is asked, you know the difference, right? This code is not right to mention there. You will be usually given m cross n matrix, then it is correct to write this because every row has m number of rows and n number of columns. So then it is correct. But if it case it has different number of columns, then this code will not work. Now let's see where else the problem will come. Problem will come here. When you're saying j less than matrix 0.size j plus plus. So second loop will only work twice. Second loop will only work twice. You're saying twice, right? It should not give me error as far as my knowledge. This should not give an error. This will run, but it will not give the proper values. See, this will not give you error because matrix 0.size, it is not out of bound. Out of bound is when you have, let's say, this value is 2, right? And you have only one column, then it will give you out of bound. But all values are greater than 2, so out of bound will not come. The problem will, it will print only up to 2 columns because size matrix 0.size, it will be only 2 columns. So this will be 3, 2, and only 2 values will be printed. 1, 2, 4, 5, 7, 8. All clear with that? While initializing, let's say, an extra array, you don't initialize it. You don't initialize. Matrix 2 will give back out of bound. Matrix 2 dot, yes, matrix 2 dot size will give you out of bound for sure. Any value greater than 2 will give out of bound. So how do we adjust in case of jagged array? Instead of using this, I can use I. So now my column is not dependent upon 0. It is dependent upon whatever values that I am using here. So each row has different number of matrix. So each row I'm calculating the number of size. There I'm printing it. If I run it now, my code will work successfully fine. I'll be able to see my output as expected. That is how you deal with jagged array. Okay, so instead of keeping it matrix 0, I will keep it as matrix I. Guys, this part everybody clear? Just let me know in the chat. Okay, cool. Then let's just copy this and write the jagged array case as well. Coming to this part, writing the jagged array case. Edge case can be whenever you have a jagged array. And then I'm going to paste it. This is my part. Okay, cool. But usually in the question, you will be mentioned n cross m matrix, that it is good or not good. That is totally fine to use matrix 0.size. Then it's totally fine to use matrix 0.size when you're given n cross m matrix. Let me also teach you how to create n cross n matrix in case anybody has issues. Okay. So if you have to take n cross n matrix, you can create something like this. This is you're initializing here. So what you can do is matrix of n vector of integer of m. That is how you can do. That's how you create n cross m matrix. So what is this code telling me? This code is telling me it's a vector of vector, or basically a 2D array, which is correct. It contains n number of rows. Each row contains the value, this many columns. This is n cross n matrix. With this is n cross m matrix using vector. I think this code is self-explanatory. Anybody has doubt understanding this code, ask me, I'll clear it. This code is clear to all, right? What I'm doing here is I'm telling it's n number of rows and m number of columns. Okay. Similarly, in case of 1D array, when you create like this, vector of integer, you create a particular vector n comma 0. So you're meaning create n values with all values 0. That's the purpose. Everybody clear with this? Just let me know. So we can move next to some other questions. Okay. Guys, all clear? Cool. Moving next. Let's solve few basic questions, then we'll go to advanced question. Come to chat. This is user-defined matrix. First, you will input m and n, then you can create m cross n or n cross m, whatever you want to create accordingly. Let's solve some question, guys, and let me check on the agenda as well. Matrix 2D arrays we are done. Now we are solving questions. Next, we'll pick up transpose. I'm parking the transpose. Let's do some warm-up questions so we guys are comfortable. Okay, coming back here. Let's do a simple question. So let's change back the dimensions of the matrix, whichever we had. I'm going to keep it as standard matrix, and column is this and this. Okay. Run the code. Let's see if everything working fine. Yeah, everything working fine. Cool, guys. I've changed back my matrix, whatever it was, for 3x4 matrix I have. What I want to do is I want to find sum of all values in the matrix. Easy question. Easy question. So just copy this and moving this. Question number 1, which I want to solve, is this. Sum of all values in matrix. Okay, this part. And yeah. Question 2, which I will take, I think that is on HackerRank also, which is diagonal values. That I will come to diagonal values. And actually it's diagonal values difference, if I remember. I'll show in HackerRank. I have seen that question. I usually teach it. Okay. Let's see this question here. Cool, guys. The question is, you're given a matrix. All you have to do is you have to write a function which takes a matrix as input or array as input, whatever you want to take, matrix or 2D array. It's totally fine, vector or 2D array. You have to return the output. For example, the output for this case will be 1 till 11 sum. It's going to be n plus 1 by 2. So it's going to be 66. Everybody clear with the question? Simple question, you have to just complete this function, a function which takes a 2D array as input. All you have to do is calculate sum of all values and return the output. Remember, this function is returning integer. Okay, so please format the condition. Do not write the complete code, just complete this function. That is sufficient for me. Vectors in Go exist. Yes, they exist. Arrays are by default dynamic there, so there is no issue. They exist. Arrays are by default dynamic there, so no need to worry. Okay. Coming to this, I want you to write, no, not the transpose, guys. The question is not transpose. The question is sum of matrix. So complete this function only. And while you are writing it, I want to do this. Write the code, write the complete code in whatever language you feel comfortable, and time and space complexity. We are going to follow the same format. Those people who are new, we give 30 seconds. In those 30 seconds, you will be covering these three parts: code, time and space complexity. You will be changing your message directly to me, so you don't spam your code to everybody. Other people don't get distracted, you don't get distracted, vice versa. Just complete this code along with time and space complexity and let me know in the chat. It's a simple warm-up question, then we'll go to next question. Cool. 1, 2, 3, 8, 4, 5, 6, 7. Let me just check the code. Big of n, big of n. Guys, please mention time and space complexity both. Some this fine. Okay. Okay. This is correct. Row into column, space complexity of 1. Cool, guys. Let's discuss the answer now. I think that part is sufficient. Guys, do not mention it as n into n until unless it is given in the question. By the way, this is not n into n. This is 3 cross 4. So it is different complexity. Okay. Let's quickly write some code. All I have to do is, if I have to take the sum of all values, when I'm iterating over all the values, I just need to calculate the sum. So I just create a value here, integer sum equal to 0. And inside this code, what I'll be doing is sum plus equal to matrix of ij. Okay. And I think I have revised in this class. What is the difference between sum plus equal to and sum equal to sum plus equal to, right? This part and writing sum equal to sum plus are different. This one is optimized. Cool. And here I can print cout sum is whatever sum I want to give. Run the code. I'll see the output. Whatever is this, sum is whatever sum. 1 is missing. Okay. Run the code. See the output. Sum is 74. Why is 74? What is the value? 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. 2 8s are there. That's why the output is 74. Makes sense. Output is 74. Coming to the approach part, that code complexity will be, just take this code. Complexity of that will be big of row into column, not big of n square. It will be big of row into column. Space complexity will be big of 1. Okay. So just copy this and paste it here and coming back. This is something you need to do in your code. Paste it, define ij. This part you can define by yourself. Define sum equal to 0. Okay. Finally, you are printing or returning the sum. Since this is returning the sum, so you better return the sum. I think all of you have done it, correct? All of you have done it. Please explain time complexity once again for me. Guys, I'll explain in detail about time and space complexity, but specifically for this, just to tell you, time complexity is nothing. It's the number of operations you are doing represented in big O notation. I'll discuss in detail about time, space, complexity, CP tricks, what happens in multiple functions. We'll have a separate class on this. We'll discuss that only. I think that will be on the next class, because tomorrow is going to be a doubt class session, which some other instructor will be taking. Okay. I will not be taking tomorrow's class. So yeah, I'm discussing that only. So coming to this part, time complexity, I'll discuss both. Why time complexity is big of row into column, why space complexity is this. First, let me write big of row into column, space complexity is big of 1. Let's discuss why is that. This iteration, you're traveling number of rows times. Here you're traveling number of columns times. So how many total iterations you are doing? Row into column. I believe nested array. If you remember, we have discussed in pattern printing, we discussed about nested array. Loop inside a loop. So it will be row into column. That is why it is big of m into n or row into column. Time complexity, everybody clear? Time complexity, everybody clear? Why it is big of m into n, row into column? Whatever the number of iterations are doing. Simple 2 nested loops. If I'm writing first time in 3, second time in 3, so 3 into 3, 9 times I'm traveling. Similarly here, 3 into 4, 12 times I'm traveling. That's why row into column. Coming to space complexity, why space complexity big of 1? Good question. Understand that. Whenever you're asked the space complexity of a function, you do not define the space complexity of the complete program. First part. I'm just asking whatever code you are writing, just talk about the space complexity of that code, not anything else. Understand this. In this function, I'm talking about space complexity of this. Why it is big of 1? How many integers I have created? 1, 2, 3. How much size I occupied? How much size I occupied? Come on, guys, be quick. I've created 3 integers. One integer take 4 bytes. Total 12 bytes of memory I have occupied. Correct? Big of 1 does not mean zero space. Just clear this part here itself. Big of 1 means constant space. This is constant space. It is not zero space. It is constant space. Even if it is zero space, we call it big of 1. If it is 1000, I will say big of 1. I will not say big of 1000. Okay, just to be clear. Since I've occupied 12 bytes, 12 bytes is a constant number. That's why I'm writing big of 1. This matrix, obviously, it is taking some size. Obviously, 100% it will be taking some size somewhere. But that code I'm not writing inside this function. So if I'm talking about the space complexity, I'm talking about this function, not the complete program. Got it? Whenever interview gives you a function to implement, talk about its time and space complexity. Nobody is asking you to taking input and printing output. Nobody is asking that. Okay, that part. That is why it is big of 1. When do I call it? Row into column is n square for this problem. No, it is not n square. It is 3 cross 4, right? This is not a square matrix, so it is not n square. Okay, cool. Coming back to this, one other thing was telling when the space complexity will be big of n, that case is when I'm creating an array of size n or vector of size n, whatever. Now, how much memory I'm occupying? I'm occupying 4 into n bytes. N is not a constant. N is a variable. That's why I will say, okay, space complexity is big of n. But if I just create integer a, b, c, d, whatever I want, now I know I'm occupying 16 bytes. 16 is constant. I will call space complexity as big of. That's the difference. Got it? Okay, cool. Then let's move to the next question. This is question number 1, sum of all values. Let's say question number 2, diagonal values difference. Let me show you the code on HackerRank, or not the code, the question on HackerRank. Then we can discuss from there itself. I remember I teach in classes, so it should be on HackerRank. Let me find the question. But in case of arrays, size will be known, right? Yes. Size will be known. If you're creating a size known array, then you will call that. If you're giving integer n, then you're creating an array of size n, that you will call the space complexity of big of n. In case of array, you're getting n as input, you're creating array of n, you will call big of n space complexity. That will not be big of n. Let me just find, I think the question name was diagonal difference hacker rank, something like this. Yeah, this is the question. So coming to this part. Yeah, that is the question. I believe all of you can see the question on screen. Everybody can see my hacker rank screen. Just let me know in the chat. Okay, let's see the question. Read the statement first, guys. The statement says given a square matrix. Given a square matrix, it means number of rows will be equal to number of columns. Okay. Calculate the absolute difference between the sum of its diagonals. First part, what is absolute difference? Absolute difference between mod. You guys know about mod, right? I mean, mathematical mod, not the modulus mod I'm talking about. Absolute difference means positive values. Absolute difference means positive values. There's many abs function, which is used for absolute. Okay. So if I say 1 minus 2, my output will be 1. It will not be minus 1. Absolute difference between positive value between the sum of its diagonals. Now remember, every square or even rectangle also, we can create 2 diagonals. I'm writing those. This is 159. This is called your primary diagonal. This particular diagonal, this is called primary diagonal. P I'm representing here. And this one, 3, 5, and 9, that is called secondary diagonal. Every square or even rectangular matrix, they have 2 diagonals. One is the primary diagonal, one is the secondary diagonal. All clear with that, or everybody knows that? Just for a better understanding, they have written as left to right and right to left, but the technical definition is primary and secondary. Okay. So just for the understanding, they've written this way. So if you see the primary diagonal sum, that is going to be 1 plus 5 plus 9, 15. Secondary diagonal sum, 3 plus 5 plus 9, 17. I need to find the absolute sum. So absolute sum will be 2. absolute sum will be 2. How to identify which one is primary? That's what I'm saying. Okay. I'll come to that question. It's very simple. It's nothing complicated there. Is this part clear? This is a question which is expecting you to do. So given a matrix, you just have to find the absolute difference between sum of its diagonals. Okay. Now let me take it to Sublime and I clear your question before I give you time. This much is sufficient for question. Yeah. Copy this, move here, and move this. Okay. Let's see the question here now, guys. Given a square matrix, calculate the absolute difference between this, left to right, right to left, absolute difference. Two things I want to clear. When you say primary diagonal and when you say secondary diagonal, what does that mean? Primary diagonals is when, which is connecting the 0, 0 to n minus 1, n minus 1. That is what we call as primary diagonal. Okay. And primary diagonal have a property that row is equal to column. So if we talk about primary diagonal elements 1, 5, and 9, if I see the 1 index of, can you define the index of 1? It is 0, 0. Okay. Similarly, if I talk about 5, it has index of 1, 1. If I talk about 9, it has index of 2 and 2. That is the property of primary diagonal elements. All primary diagonal elements, they have the row number and column number as same. Row index and column index is same. This is a property of primary diagonal. Got it? Primary diagonal is a diagonal which is connecting 0, 0 to n minus 1, n minus 1. Coming to secondary diagonal we call as matrix. This one is row 0, 1, 2, and this is row minus 1. This is called the secondary diagonal. Something which is connecting the last row, first column, this part to this part. Okay, let's see their index also. 9, 5, 3. The index of 9 will be matrix of 2 and 0. That will be 1 and 1. That will be 0 and 2. This is your primary and secondary diagonals. Now I think it clears the difference between primary and secondary diagonals. Cool, guys. So this is your question. You're given a square matrix. Remember, it's given a square matrix. So do not confuse like n into m. It is going to be n into n all the time. Okay, given in the question. This can be extended to rectangular. No doubt this can be extended. Okay. But as of now, this question, we are considering only square matrix. So let me highlight the word also. Yeah. Remember when you're mentioning time and space complexity. The whole thing is you have to calculate the sum of primary diagonal elements. You have to calculate the sum of secondary diagonal elements. Then you have to return me the absolute difference. Okay. So if I talk about this, it will be 15, it will be 17, and it will be 2. This is the function I want you to complete. Integer, diagonal difference. You are given vector of integer matrix. Whatever language you comfortable, just return me this. Remember, this is going to be absolute difference. So please don't return negative number. This will be absolute difference. Okay. This part clear, guys? Question is clear before I give you time. Anybody has doubt in the question, please feel free to ask. If the question is clear, type clear in the chat. Then I'll give you time, then you can write the code. Anybody has questions before I give you time, let me know. All clear? Cool. Just one more thing, guys. When you're completing this function, I'm giving a brownie points in case anybody can solve in big of n time complexity. Big of n square, everybody can solve. If somebody can solve in big of n time, brownie points for that person. Okay. Cool. I think question is clear. You are clear with what function you have to implement. 30 seconds on the clock. Write the code, write the time and space complexity. If you are eligible for brownie points, so you'll get brownie points as well. Time complexity, big of length, it's a square matrix. Cool. Cool guys, I think let's discuss it. I've seen various implementation in different languages. It's good to me. What I was expecting is the brownie points if you can solve it in big of n. 3 people have solved in big of n as of now. 4. Okay. Cool guys, let's discuss both the approaches, then we'll take forward from there. First one is brute force one. Obviously, everybody can solve in brute force. Okay. How will you solve it in brute force? You need to find the primary diagonal and you need to find the secondary diagonal. So I can do is brute force as big of n square. Since it is a square matrix n cross n, so I equal to 0, I less than n, j equal to 0, j less than n. All I have to do is I need to keep two variables, which is diagonal sum. So integer d1 equal to 0 and d2 equal to 0. First, d1 is a diagonal sum of primary elements and d2 is a sum of the secondary elements. All I have to do is, I know the property, if I is equal to j, then it is primary diagonal. I will do d1 plus equal to matrix of I comma j. Okay. And if it is going to be I equal to I plus j equal to n minus 1, then it's going to be d2 plus equal to matrix of I comma j. And at the end, all I'm going to do is, after this for loop, I'm going to return absolute of d1 minus d2. That's it. That is sufficient enough to go. Okay. Time complexity is big of n square because we're running two nested loops. That's why it is a brute force approach. One more thing, guys, those who don't get this second part, let me explain again. Understand the property of secondary diagonal elements. In second diagonal elements, if you see the index of 2 and 1. If you multiply 2 plus 0, you get 2. You get 1 plus 1, you get 2. You get 0 plus 2. There you also get 2. Okay. Their sum is same, and this is nothing. This is 3 minus 1. This is 3 minus 1. This is 3 minus 1. So just like primary diagonal has a property that row is equal to column, secondary diagonal have also a property. That property is row plus column is equal to n minus 1. Got it? That is what I want you guys to figure out. Is this part clear to all before going to the implementation? Just like primary diagonal have a property that row is equal to column, or better write it like I equal to j, like this. They have this property. That's the property of primary diagonal elements. Similarly, second diagonal elements have a property that I plus j is equal to n minus 1. That is second diagonal properties. This property is clear to all. You can verify with any matrix that you want, any square matrix, this answer will always be true. Okay. Now, once you have got this relation, now it becomes very easy to solve the question. The only trick about this question was to finding this relation. Okay. Now you can run a nested loop. You can find I plus j, I equal to j. It's going to be primary diagonal. I plus j equal to n minus 1. That is going to be secondary diagonal. And finally return the absolute difference of the same. That will run in big of n square. Time complexity big of n square. Okay. Space complexity big of n. But is it efficient approach? No. I can solve it in big of n to get my brownie points. How I can solve it in big of n? Let's see. Optimized approach that I can solve in big of n time. Let's see the code for big of n. Just understand one thing. The moment you realize this, I plus j equal to n minus 1, that time only you can solve it in big of n. Why? When I'm writing I plus j equal to n minus 1, can I write, or this basically implies j equal to n minus 1 minus I. Yes or no? Simple mathematics, when you're writing a plus b equal to c, can you write c equal to b minus a? It will go to the RHS, it will change its sign. So this will become j equal to n minus 1 minus I. What am I doing actually? I'm trying to represent j in the representation of I. Understand what I'm doing here? I'm replacing I. You guys know simple math, simple equations, right? If I'm writing a plus b equal to c, I can write b equal to C minus A. This is called eliminating the variable. You are eliminating B by representing in terms of A. Agree? Simple mathematics equation you must have read in 4th, 5th class or whatever class it was, right? What is the advantage of eliminating the equation, eliminating the variable here? If you're eliminating J, you're representing J in terms of I. If you eliminate J, I can eliminate this nested loop. There's no need of J now. Only with I can use both I and J. Agree? Understand the intuition, then move to the code part. The intuition is, if I know this relation, I can represent J as equation of I. This is called eliminating the variable in mathematics. Okay. What do I get by eliminating this J? I can remove this nested loop. This is taking big of n square. If I remove this, only one loop will be required that will take big of n. Okay. So just copy paste this code. By eliminating the variable, I can solve it. Just copy it in this part. Writing the code here. I have eliminated this loop. This is not required. This is not required. All I will say is, this is also not required. This is also not required. D1 value will be I comma I because I is equal to J. And for them, here I will replace n minus 1 minus I. I got D1, I got D2, and I return the absolute difference. Time complexity will come big of n, space complexity becomes big of n. Simple 4-5 lines of code. That is my expected output. That is the code which interviewer expect. This part, everybody clear? Just let me know in the chat. Easy. Simple mathematics, and programming is mostly mathematics, nothing too difficult. Algorithms is mostly mathematics, to be precise. Okay, that we have done. We have solved with brownie points as well. Let's move to next question, which is transpose of the matrix. Same definition of transpose, which you must have seen in class 10th or 11th whenever matrix was introduced. So let's quickly write a matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your matrix. Okay. The transpose of this matrix will be when your rows become columns, your columns become rows. Okay. So think it this way. This is my first row. This is my second row. This is my third row. Imagine I take my row out and I turn it by 90 degrees. So it will become a column. I take this row out, I turn it by 90 degrees. It will become a column. I take this row, I turn it by 90 degrees. This will also become column. All agree? If I just take my row and I pull like a lever and I turn it by 90 degree clockwise, this will convert into a column. Something like that. And that can be also make a question. 3-degree transformation, 360-degree transformation. Anyhow, transpose of this will become, it will become 1, 2, 3. It will become 4, 5, 6. This would become 7, 8, 9. That is what I was referring. When your row become column, 1, 2, 3 was a row. Now 1, 2, 3 is a column. 4, 5, 6 was a row. Now 4, 5, 6 is a column. 7, 8, 9 is now a column. Row will become column, column will become rows, vice versa. Rows become column and vice versa. Okay. That is the question you have to do now. So you're given a matrix. First of all, transpose definition, everybody clear? Anybody has doubt in understanding transpose? Let me know. Transpose matrix, everybody clear? Okay, cool. Now your question is, and read the question properly, you have to print the transpose of a matrix. Print the transpose of matrix. Okay, so let's keep it here. It's going to be a void. It's going to be transpose. And I want you guys to print the transpose of the matrix. So this would be same vector of integer. Matrix will be given. This is a void. It is not returning anything. This is a function you need to complete. Complete this function, write time and space complexity, 30 seconds on the clock. But prior to that, just let me tell you, guys, whenever we have done 2 questions, we are doing sum of matrix and sum of diagonal values. Whenever you're keeping sum, whenever you're keeping product, always prefer to use long instead of sum. So this code also, Instead of keeping it integer, always prefer to keep it long or long, depending upon the range of that you can see in the constraint. It's a good idea to keep whenever you're taking sum or a product, always keep it as long or long, depending upon what constraints are given. If my constraints are up to 100, I can 100 into 100, I can keep up to sum. But if it is 10,000 into 10,000, that will not fit into integer. So keep it into long or long. Similarly, here it's a good idea to keep it as a long. Okay, just for the understanding. Coming back to this question, you are given the matrix. You want to print this transpose of the matrix. Remember, the question is to print the transpose of the matrix. That's all. This is the function you're expected to complete along with time and space complexity. Before I give you time, anybody has any doubt, please ask. If no doubt, then I will start the timer. Okay, I think now we can discuss it. Before that, is transpose only for square matrix or is transpose for rectangular matrix also? Is transpose only for square matrix or can the transpose for rectangular matrix also exist? Both exist, right? So simply put, if my matrix is this, if my original matrix is this, to be precise, it is m cross n, the dimension of my transpose matrix will be what? It's going to be n cross m, because rows will become columns, columns will become rows. Simply put that. Okay. The two approaches in this case is, guys, read the question again. I am saying print the transpose of the matrix. In the question, it was asked to print the transpose of the matrix. You do not need to create a separate array to print it. That was the hint that I wanted you to pick up. When the question says only print, the question was return the transpose. Then you have to create another array of the same size, n cross m size, then you have to return it. But this is about this. So first, if you're creating separate matrix, then you have to create an array of, if it is m cross n, you have to create n cross m, and then you have to give the value. Okay. So same code, I equal to 0, I less than m, I plus plus, for j equal to 0, j less than n, j plus plus. Here, what you can do is print the matrix of j and I. That's it. Okay. Either you can do this, that will be your second approach. Direct print without extra matrix. So one thing you can do is you can create extra matrix n cross m size. Then you can define your transpose I comma j equal to matrix of j comma I, and then you can return the transpose matrix, or you can directly print without any extra space. Time complexity will be same in both cases, big of m into n. Space complexity will vary. So if you're creating another matrix, that will be n cross m, because you're creating that matrix. In case of this, just copy this and move here. Time complexity will be this, space complexity will be big of n. So whenever the question says only print it, directly just print it. Whenever the function is expected to return something, then you have to create and return that array. Okay. If I change this to from void to vector of vector, then you have to create. There is no other option. Both approaches clear to all, guys? How to find transpose of a matrix? Just let me know. Clear? Let me do one thing. Let's go to lead code. Let's quickly print the transpose of the matrix as well. So this is our hacker rank question. I believe all of you would have solved it. Coming to this, let me print transpose of matrix as well. No need to change primary diagonal, right? Correct. In this case, I will just check this, copy this, and come here. Put an handle. All I'm going to do this, instead of ij, I'm going to print ji. That's all. Transpose is, and here I will say original matrix is, something like this. Okay, I think we are good to go. Let's run the code and see. What is that? This part is fine. Transpose matrix is 74. Transpose matrix is 74. Okay, I'm printing some here. The printing a loop. Yeah, we're printing a loop. Let me just check. What's going into a runtime matrix? I equal to 0, I less than matrix dot size. J equal to 0, j less than matrix dot size. All I'm doing is printing j comma I. Is this a jagged array I've created? No, it's not a jagged array. It's a 3 cross 4 matrix. This is fine. Row 3, row 4, it is correct. IJ I'm printing. Let me check. Okay, this is working fine. So if I'm replacing it with j and I, that's where it is giving the problem. Let me check again. Transpose of matrix. I equal to 0, I less than matrix dot size, I plus plus, j less than matrix dot size because I less than j. No, that's not the problem. I less than j condition I have not given. Somewhere it is running into the heap memory. Let me check this code again. I'm printing j and I only. That is where it's running into the heap memory. So that's what I'm checking. Matrix 0 size is 3 cross 4. Every time calculating row and column length, we can initialize it in beginning. I have initialized it in beginning, that's fine. What is running into heap memories? That's my concern. A of j of I, which is correct, n cross m, that is also correct. Okay, let me check. Number of rows is 4, number of columns you're printing is 3. That is why it is accessing an invalid address. Okay, let's do one thing. Instead of keeping this, let's make it first for loop outside, second for loop inside. Matrix 0 will always be there, guys. That's not the problem. Yeah. One four seven, that is correct. 258, that is correct. Yeah. Now it is giving correct output. That first code, that was for square matrix only. This is for rectangular matrix, because in case of rectangular matrix, m cross n will not be equal to n cross n. That was a problem. It was giving into runtime memory. We're trying to access a memory which does not exist. That's why it was going into heap memory. Anyhow, this is for m cross n. Can we do transpose without creating extra array storing the result in case the function has to return the transpose? In case the function has to return the transpose, then you have to create another matrix and return it. But in case the function is void, you just need to print it, then you can do it in space as well. This is called in space solution. Other part is using extra matrix. Just to tell about, guys, if the first code will work for a square matrix, this is a different matrix, n cross m. So m cross n will not be equal to n cross m in case of rectangular matrix. So this is the right code for rectangular matrix. Copying this part and moving to Sublime. Yeah, directly print here, replace this part, replace this here. That part is correct, and this part we have to modify. Cool, guys. Time complexity big of m cross n or n cross n. Technically, it should be n cross n, whatever you call. Space complexity big of n. This is called in-place solution, where you are not occupying any extra space. This is called in-place solution. Okay, and that is with extra space. This part, I believe, is also clear. This transpose exists for jagged array. You can create for jagged array. You can create for jagged array. but you have to create for separate sizes. So first you need to store the sizes in a separate part, and then you can keep a matrix accordingly. Then you can do it. If you directly want to print it, only thing will change here. Instead of 0, it will change to I. But transpose do exist for jagged array also. Okay. Can you please mention it's for rectangular matrix? Yes, it is for rectangular matrix. This code, it is for rectangular matrix because I cross j is not equal to j cross I. So what I'm doing is I'm first traversing in the case of j, then I'm traversing I, am printing ij. Either you do it this way or you do I outside, j inside, and ij. But the problem with that code is when your number of columns will become more, it will give you runtime error. That's what we have seen right now, right? So either you go with this way, first part, or you go with ji, both are correct. But please do check the number of rows and number of columns. Okay. Guys, is this part clear? Cool. In case of Jagged, we have to create new array. That's what I'm saying. If in case you don't need to create an array itself. You have to create an array to store the values of each, because in case of Jagged array, every row will have different number of columns. So you need that mapping somewhere. Then you create it. If you don't want to store it, then you can do it any place. You can just write matrix of I. It will work fine. No issue with that. Okay. Yep. Array of nm will differ. Mn will give error. That's what I've written, right? Instead of that, that's why I modified the loops. Now it will not give you error. You're talking about jagged arrays. Yeah, that's what I'm saying. We need a different array in case of jagged arrays before running this loop. That array will store the mapping, which particular row contains which number of columns. Cool, guys, let's move to the last question of the class, which is maximum sum column in a matrix. It's a really good question. So the question is, let's take the same matrix that we are using. It's on NIT code. Let me just get it. Yeah, this part. So if you see here, what I have to do is I have to find maximum sum column in a matrix. The same question can be extended to maximum sum row in a matrix also. Now, if you see here, how many columns this matrix has? How many columns this matrix has? 4 columns, right? So let's write the sum with each column. So column 1 sum, similarly column 2 sum, 3 sum, 4 sum, and all. Column 1 sum, column 2 sum, column 3 sum, and column 4 sum. So column 1 sum is what? 8 plus 3 plus 2 plus 1. Just let me know in the chat. Oh, sorry, not row, column sum. So that will go into 12. 2 plus 5 plus 8. Okay. This is 12, 15, 18, 29. As part of my output, I expect that which column has the maximum sum. So my output should be column 5, or just 5 is fine. Column 5 or just 5 is fine. As the output, I want the maximum sum column. And we can further extend that not just the maximum sum column, I want the maximum sum also. So I want my output this way. Column is 5 and max sum is 29. Let's make it this way, which will help you more. So question is, you're given a matrix. All you have to do is you have to find the maximum sum column in a matrix. Yeah, I'm following n plus 1 indexing. I'm following 1 indexing. That's why I'm writing 5. So how you handle in the code, it's up to you. I'm following I plus 1 indexing or 1 based indexing. That's why it is 5. Okay. 1, 2. This is 4 and index is 3. Index is 4 and index is 3. Basically, I'm following 1 based indexing. That's what I'm saying. So my column output should be 4 and should also print me what is the maximum sum, which is 29. So two things you have to do. You're given a matrix. You have to find me which column has the maximum sum, first part. Second, you have also tell me what is that maximum sum. Same approach can be extended to minimum. Same approach can be extended to maximum sum row, minimum sum row. So 4 questions can be derived from it. So even if you do one question, you are solving 4 questions. Everybody clear with the question? Even if you're solving one question, technically you're solving 4 questions. So let me write variation also. It can be maximum sum row. It can be maximum sum row. It can be maximum sum column as well. Even if you solve one question, technically you're solving all the 4 questions, right? So that should be fine. That's how variations are derived in the interview. Coming back, everybody clear with the question, what you have to do? You're expected me to tell two things. What is the column in one-based indexing? And second, what is the maximum sum? That is what you are expected to return. That time let me write, it's one-based indexing. So please handle that in the code accordingly. I'm using one-based indexing. This is the function you need to write. Void, you are given maximum sum column, vector of integer, that is you are given in terms of matrix. Tell me the approach, tell me the code, time and space complexity, whatever language you feel comfortable in code. Is question clear to all? Just let me know in the chat. Is question clear to all? Just let me know in the chat. Okay. One more thing, guys. Try to make your code as generic as possible. What do I mean by as generic? If I have to solve these 4 questions, I can reuse your code with minimum number of code changes. Keep your code as much robust as possible. Okay. As much robust, as much as modular. So even if I have to extend your code to support these kind of variations, I should be able. Think it like an API I'm designing. API can be 4 types, right? These 4 types of API endpoints are there. So keep your code generic, which I can just change the endpoint and I can pass some parameters and I can use the same source code in your business logic. If I talk in terms of microservices. So try to keep it as generic as possible so it can support other variations with minimal code changes. That is what I will qualify as a good quality code. So I'll expect a good quality code. Got it? Write me that code which can be easily extended for these variations. Okay. Most of you have given the right answer. Time complexity is correct. Space complexity is correct. Let's directly code on lead code. Then we can copy paste at the end. Okay. So what I'm going to do is I just need to find maximum sum column. Let's write it here. All I need to do is I need to create an index as well as I need to give you the maximum sum. So I need 2 variables. So first index, first is my index. I'm keeping at -1. This is the code for maximum sum column. Okay. Index is -4 and then I'm talking about maximum sum. So that I will initialize with integer min. It's always a good idea, guys, that you initialize it with a very integer min value whenever you find the maximum. Whenever you find the minimum, initialize with integer max. Okay. So this part is there. Now I start doing the iteration. So just copy paste this code. Not actually this code, copy paste this code, row and column part. Yeah. I equal to 0, I less than this, j equal to 0, or I have already defined row and column. So let's use row and column this time. Row and column. Inside my row and column, what I have to do is I need to maintain the sum. I need to maintain the sum of each and every column. So what I'm going to do, I'm going to create a sum here, integer, column sum equal to 0. Because my column sum will change for every value. Agree? My column sum will change for every value. And inside this, I'm going to keep column sum plus equal to matrix of j and I. I'm finding column, guys. I'm not finding row. So matrix of J and I, that will give me column sum. Okay. After doing that, what I need, I will compare if my column sum, if my column sum is greater than maximum sum, then I replace column sum with maximum sum. That part. And my index, which I'm keeping, I'm going to keep it with I. At the end, all I'm going to do is I'm going to print one base indexing. So I'll print cout. I needed column index plus one because I need one base indexing. And similarly, cout maximum sum. This is going to be max sum, which I'm going to update. My max sum is going to be column sum. Is max sum. That's all. Okay, this is the code which I was talking about. Let's quickly clear console. Let's run it and see. Transpose is fine inside this. Less than row, J less than column. Matrix of J of I, again same issue. Okay. Use of undeclared ID column sum. Okay. This has to be outside. Yeah, this is fine. No, this code is working fine. I was checking formatting, that's all. So handle I have given here. Let me give one more handle. Yeah, row columns are fine. Okay, now let me just complete to the last part. See guys, this is the code which I was talking about for finding your maximum sum column. In your maximum sum column, yeah, I will take the question. Further case, support my third and fourth row intercheck. I will check, I'll check. What I'm doing in my maximum sum column is integer index equal to -1. I need two things. What is the index of that in one based answer? So for that, I will be adding after at index plus one. So that is fine. I can keep zero based indexing here. Later, I can add index plus one. So I will initialize it to -1. Whatever the index will come, I will replace it with that. Second part, I'm keeping the maximum sum as integer min. Whenever you have to find the maximum value, good idea to keep it as integer min. Whenever you find the minimum value, good idea to keep it at integer max. Okay. All I'm doing is I'm iterating over the matrix J equal to 0, J less than column, I equal to 0, I less than row. Either you do it this way or you do it with, I mean, J outside, I inside, and IJ, or you do it I outside, J inside, and JI. The only difference is please cross check whether you have more number of rows or you have more number of columns. In this case, I have more number of columns as compared to rows. That is why I'm keeping this part so that you can pass under if check. That's what you were asking, right? That you were asking about if check. So if you have less number of rows, you can use I and J. If you are using more number of rows, then go with outside 4 and inside I. Okay. Now you're comparing is every column sum you are calculating. If that column sum is greater than your maximum sum, then you are implementing maximum sum equal to that column sum. So first column sum, it will become whatever it was. 147, it was 12, then 18, then 19, and then 29. So it will be replacing with 29. Index equal to I, that finally give you C out. I'll take that question. I'll take that again. Is this part clear to all? Just let me know. This is the complete code I'm talking about. Yeah. Okay. Now coming to your question, why I'm putting J outside, I inside. Guys, in this matrix, I have more number of columns, 4 columns and only 3 rows. Understand? 4 columns and 3 rows. So matrix of, let's write it 2, row 2 and column 3. This part exists. This part exists. Agree? But row 2, it means this part I'm talking, column 3, 11 I'm talking. But if I write like this, matrix 3, 2, that does not exist. If I'm using I and then J, if I'm using I and then J, this is going to run into a memory which does not exist. It is trying to access a memory which does not exist. That is why I'm keeping J and I. If we have more number of columns, prefer J over I. If you have more number of rows, then I and J. Both is fine. Or even better, you want to make it generic, you can just put a if and else case. Got it? Cool, guys. Same problem that we faced in transpose also. The reason was, in the transpose also, we did the same thing. The reason was when we were trying to access this memory, 3, 2, that does not exist. That is why it was giving you runtime error. Okay, guys, I think that was the last question. So let me just copy and paste to Sublime my question. Yeah, just 1 second. This is the final code. Paste it here. Time complexity, space complexity. Index equal to I should be if block. I'm taking just 1 second. Big of row into column and space complexity is going to be big on. Yeah, now ask the question. Now ask the question. Index equal to I should be inside if block. I didn't get this part. Oh, okay, yeah, correct. This will be inside if block. Otherwise, it will always override with the last value. This is correct. Only in the if case, you will update the index as well as your maximum sum. That is correct. Okay. Cool, guys. Is this part clear to all? That was our last question. Then we can go ahead and do a revision. We did a lot of topics today. So let me just cover from the scratch what we have discussed. Yeah. Coming back. So we started with first part. We started with quick revision. Then we did the matrix 2D array. We have done the transpose. We have done this. And since we have done this, we are able to do this as well. I hope this all 4 variations you can do, right? These 4 variations you can do. Even if a done variation, 4 variation can be done. That's why I write a code which is extendable to all other variations. Okay, coming back, guys. So we discussed about few questions that you guys asked. Then we moved to metrics. We understood how to initialize a matrix, how to compare with different 1D matrix with the 2D matrix, 1D array with 2D array. And then we finally moved to vectors. What is the difference between a static data type and a dynamic data type? Then we discussed about the difference of vector, why vectors are useful, how to create in vector, what is the drawback with the arrays, why there's a limitation on the size of the arrays. Then we write the code for matrix. Then we move to jagged array. We talked about jagged array. We write the code for jagged array as well. That 0 will be replaced with I. If you take user-defined numbers, that's how you can take in vector. Similarly, array as well. Then we move to first warm-up question, which are sum of all values in a matrix. We did that. Then we did a hacker rank question, which was diagonal values. Diagonal values difference. We solved this question into 2 parts. First part, big of n square. Second is only big of n. This is the answer which is expected in the interview. Big of n complexity, only this 4-5 lines of code. That is what we expect as interview. Okay. Then we move to transpose of a matrix. We discuss again 2 approaches. Either I can create a separate matrix and print it, but if the question is only about printing it, there is no return type, then in that case, return type means void is their return type. Then in that case, I can directly print without creating any extra matrix. Time complexity will remain same. Space complexity will become big of 1 because that will be in place. Next, we have maximum sum column in a matrix. That was the last question. So this also covers the variation of these 4 questions. So this is our code for that. Yeah, this is my code for that. I need to find the index as well as I need to find the maximum sum. So whenever any column has greater sum, I'm updating my index as well as I'm updating my maximum sum. At the end, I'm printing them both. This is what we have done. Now coming to the next class or the agenda of next class with me is going to be, we are going to cover time and space complexity in detail. Then we'll go to CP trick to pass our test cases if you guys are interested. Okay.